Discussion on leadless pacemakers. Weakest link in the pacemaker system is considered to be its lead, sometimes called its Achilles heel. This is because the lead system is prone for infection, fracture, failure, and dislodgement. The more the number of the leads, the more the complications, as in sophisticated systems like dual-chamber pacemakers and biventricular pacing devices. The incidence is compounded over time with longevity of the device and the recipient. The risk of lead extraction is also significantly high in case it is needed, hence the need for a leadless pacemaker system. Micra transcatheter pacemaker system can be delivered percutaneously using a delivery system via the femoral vein. It provides right ventricular sensing, pacing, and rate responsiveness. It uses an accelerometer sensor for rate responsiveness. The device is delivered in the right ventricle. Micra transcatheter pacing study group successfully implanted the device in 719 of 725 patients enrolled for a multi-center study. Primary safety endpoint was freedom from system-related or procedure-related major complications. Primary efficacy endpoint was percentage of patients with low and stable pacing capture thresholds at 6 months. Cutoff was 2 volt or less at a pulse width of 0.24 milliseconds and an increase of 1.5 volts or less from the time of implantation. Major complications were compared with those in a control cohort of 2,667 patients with transvenous pacemakers from 6 studies published earlier. Rate of primary safety endpoint was 96% and primary efficacy endpoint 98.3%. Complication rates were significantly lesser than the historical control cohort. A feasibility study of accelerometer-based atrioventricular synchronous pacing with a ventricular leadless pacemaker was published in 2018. Micro has a 3-axis accelerometer. They developed a custom software to detect atrial contraction using the accelerometer to enable AV synchronous pacing. The Marvel study tested the algorithm downloaded into previously implanted Micra devices. AV synchrony was defined as visible P wave on surface ECG followed by a ventricular event in less than 300 milliseconds. A total of 64 patients in 12 centers across 9 countries were evaluated. Patients were implanted with a Micra for a median period of 6 months. 33 had high-grade AV block while 31 had intrinsic AV conduction during the study. Average duration of AV algorithm pacing was 87% in those with high-grade AV block. 94.4% AV synchrony was noted in those with intrinsic conduction. Here the pacemaker senses the mechanical activity of the atrium rather than the electrical activity which is sensed by conventional AV sequential pacemakers. In an innovative case report, a new leadless pacemaker was synchronized with an existing transvenous atrial pacemaker. Patient had sinus node dysfunction and intermittent Mobitz type 2 AV block for which a dual chamber pacemaker was implanted earlier. Pacemaker interrogation after syncopal episode showed right ventricular lead threshold of 5.5 volts at a pulse width of 1 milliseconds. There was only less than 1% right ventricular pacing and there was a previously documented chronic malfunction of right ventricular lead with impedance more than 3000 ohms. Atrial lead was stable with intact parameters. Patient was on hemodialysis using a left arm arteriovenous fistula for end-stage renal disease. Hence, risk of bleeding and infection for lead extraction and implantation of a new lead on the left side was deemed high. Considering all aspects, they decided to go for a leadless pacemaker and a Micra AV was implanted. Previous pacemaker was programmed to atrial pacing, atrial sensing, inhibited mode. Micra AV was synchronized to the atrial contraction resulting from atrial pacing of the previous transvenous pacemaker. Thus, the patient had two pacemakers interacting to produce AV synchrony after careful programming. A systematic review and meta-analysis on safety and efficacy of leadless pacemaker has been published. They identified 36 observational studies of nanostim and Micra leadless pacemakers, of which 69.4% reported outcomes for Micra. In 5 studies with 1-year follow-up, Micra was associated with 51% lower odds of complications compared with transvenous pacemakers. 98.96% of the 1,376 patients implanted with Micra had good pacing capture thresholds. They concluded that studies report outcomes for Micra associated with a low risk of complications and good electrical performance up to 1 year after implantation. They opined that further randomized controlled trials are needed to support the widespread adoption of these devices in clinical practice.